Okay, so we've been talking about this empirical rule and the bell curve. And the weakness, as we pointed out, is if a number falls in between one of these standard deviation steps, you really can't figure out the percent. So there's another tool that works similar to this called a z-score. And what a z-score does is tells you how many standard deviations above or below the mean a number is. So the formula for the standard deviation, or for the z-score, I should say, the formula for the z-score is the z-score is found by taking the number minus subtracting the mean, then dividing that difference by the standard deviation. So up above there, we said we had that $130,000 house. Well, we had a mean of 118,000, a standard deviation of 18,000. That $130,000 house would have a z-score of 130,000 minus the mean of 118,000 divided by the standard deviation of 18,000. So the first thing we do here is we'd subtract. The 130 minus the 118 is 12,000. Then we divide by that standard deviation of 18,000. 12 divided by 18 is 0.667. Or 2/3, yep. So what that is telling us is the 130,000 that's positive here is 2/3 of a standard deviation above the mean. So it's not quite, it's less than one standard deviation above the mean. Now the real strength of a z-score, the reason that z-scores are used is you can compare two things, two items, we'll say, from different populations. What does that mean? Well, let me give you an example. Let's go back to buying a home again. And let's say you have two different areas you would like to move to. In area 1, we're going to call it area A, the mean for that 3-bedroom, 2-bath house still is what we just saw. That 118,000 with a standard deviation of 18,000. In area location B, let's say it's a little bit more of a secured community, close to a police station, so you're fire station, so you got protection. The mean price there is $143,000 with a standard deviation of $16,000. And let's say you have narrowed your search down to 2 homes. You found a home in area A that is priced $140,000. You found a home in area B that is priced at $163,000. Which one is a better deal? Well, we find the z-score. The z-score for this first house, it's 140,000 minus the mean, which is 118,000, divided by the standard deviation of 18,000. So subtracting there, 140 minus 118 is 22. 22,000 divided by 18,000 is going to give us what? 1.222. Yep. Over here on the other side, our $163,000 home, the z-score will be 163,000 minus what? That mean is 143, yep. Divided by that standard deviation 16,000. So we subtract here 163 minus 143. That house is only $20,000 more than the mean. This one was $22,000 more than the mean. But the standard deviation is only 16,000. We divide that out. 20,000 divided by 16,000 is 1.25. This house here is 1.25 standard deviations above the mean. This one's 1.222. This one's more expensive compared to the other houses in its area. This one is not quite as expensive. Now it also tells you those z-scores are really, really close to the same, aren't they? 1.22.
Say, is that really, they seem really close.
Yes, they are. And that's what it's saying, is these houses are really, really close to the same compared to the houses within the neighborhoods they're at. This one is slightly less expensive. But the question is, if you really prefer this neighborhood, there's not enough difference to really sway your decision. This can be used for, starting wages, stuff like that. Used for testing. Let's say when you got into school here, you had to take your tests. Let's say you took your math test and you got a score of 58. And on the English test, you got a score of 66. Does that mean you're better at English than you are at math? Well, no, they weren't the same test. Now, if two people took that test, let's say two people took the math test and one scored a 58 and the other scored a 66, yes, the person with the 66 did better on that math test because it was the same test. But these are two different tests. So to compare how you did on each of those tests, we need some more information. Let's say that the mean for the math test is a score of 50. With a standard deviation of, I don't know why I put 50,000 there. The score of 50 with a standard deviation of 4. Right, so I'm just writing those zeros from the home loans right now. The score on the English, the mean score on the English test is 56 with a standard deviation of 6. So which one's more impressive? Well, right now I want you guys to find the z-score for each of those. Okay, so for the math, our z-score is going to be what?
2.
So yeah, 58 minus 50 divided by 4, which is 58 minus 50 is 8, divided by 4 is 2. Yes, that is a z-score of 2. For the English, how do we find it?
66, subtract the 56, and then divide by 6.
Okay, so 66 minus 56 over 6. 66 minus 56 is 10, Again, at first glance, you're 10 points higher than the mean, and over here you're only 8 points higher than the mean. But we have to divide by a standard deviation of 6. This is 1.67, or 1 2/3. So you scored a full 2 standard deviations better than the mean on the math test, and only 1 2/3 standard deviations better than the mean on the English test. So your math test is a more impressive score compared to the other scores on that test.
Must be tech English.
There you go. One more example here of how this might be used. I mean, entrance test, probably analyzing that isn't the most useful thing you do tonight. But let's say you're a manager at a retail store. You have several departments. And you have narrowed it down to 2. You need to get rid of a salesperson. And you have it narrowed down to 2 people. So we're going to call them Pat and Peyton. You decide that next week, whoever has the lowest sales has to go. Pat has sales of $1,200. Peyton has sales of $2,800. Does that mean we're saying goodbye to Pat?
No.
No. Pat is in toys. And for last week, the mean sales for all people in toys was $2,100. With a standard deviation of $400. Peyton is in electronics. Last week, for all salespeople in electronics, the mean sales was $4,000 with a standard deviation of $500. So let's find the z-scores. For Pat, Pat's z-score will be 1,200 minus 2,100 over 400. Well, 12 minus 21 is a negative 900 over 400. So that's a negative 2.25. So Pat's z-score is a negative 2.25. What's the negative telling us there? He was below the mean. The z-score of the mean would be 0. Anything below the mean has a z-score negative. Anything above the mean has a z-score positive. For Peyton, the z-score is going to be 2,800 minus 4,000 over 500. Bless you. So 2,800 minus 4,000 is a negative 1,200. Divided by 5, that's a negative 2.4 standard deviations. So who was really worse? Peyton was more standard deviations below the mean, negative 2.4 compared to negative 2.25. So you can see how this is a very useful tool. You compare things that are not necessarily related by what you're doing is you're comparing them back to their own population and seeing where they stand within their own population and comparing that position to each other. Okay, enough on percentiles. Or percentiles, on z-scores. Like I said, that z-score is a very useful thing, but we're going to leave it off of there. The next thing we want to find is we've talked about mean, median, mode. We want to look at this for grouped data. Remember we looked at frequency tables last week. Let's look at like number of classes and the frequency. Remember, if somebody had 0 classes, they weren't a student. So we're going to start at 1, 2, 3, 4, and let's say nobody in our group that we surveyed had more than 5 classes. We have a frequency here. Let's say that we had 8 people that were taking 1 class, 14 that we're taking 2 classes, 27 that's taking 1 class, 31 that's taking 4 classes, and let's see, where are we at there? 22, 49, 80. Let's say there's 20 that's taking 5 classes. If I want to find the mean, I have to remember, when we find the mean is the total divided by n. N is the number of items in the list. Well, first of all, how many items are in this list? Not 5. There are 5 different values. But the 1 appears how many times? 8 times. And the 2 appears 14 times. That's what that frequency tells us, remember. As we have a list of these out, there are 14 2s. There are 27 3s. So n here is found by adding up that frequency column. And what do we get when we add those up? Should be 100. That's what I was shooting for. Now to find the total part of the mean, well, we have to add in 8 ones, don't we? To do that, we're just going to take the number times the frequency. Because if we add in 1 8 times, that's just 1 times 8 is 8. To add in 2 14 times, well, that's just 2 times 14 is 28. To add in 3 27 times, 3 times 27 is 81. To add in 4 31 times, 4 times 31 is 124. And to add in 5 20 times, 5 times 20 is 100. So I took the number times the frequency. And I add those up to get my total. What's that total? $241, is that what you get? $341, I mean, sorry.
828, 81, 128. I got 245. Oh, wait.
Careful.
Hold on. No, never mind. I'm reading it wrong. Sorry. Just a little tired.
So I'm getting 305, 333, 341. Okay. So then the mean is just that total of 341 divided by n of 100. My mean is 3.4. So the mean number of classes taken by a student is 3.4. The median. The median is sometimes a little bit harder to conceptualize. We're going to find the position of the median.
341.
What's that?
Should the mean have been 341 over 100?
Yeah, I don't know why I got a 0. I'm sorry. Yes, that is 341 over 100, so it's 3.41. I'll give you guys a second to correct it. The little hamster is not fully on the wheel. Oh, at this point in the night, the hamster is just laying beside the wheel trying to swat it with his paw. So for the median, to find the position of the median, n is 100, so it's 100 times 0.5 is 50. So that's telling us is the median is between the 50th and 51st number in the list. Now remember, as we're listing these out, there are 8 ones in that list. And there are 14 twos. How many numbers are there so far? 8 ones and 14 twos make 22 numbers so far, right? 8 plus 14. If I were to list them out in a list, I would have 1, 2, 3, 4, 5, 6, 7, 8 ones. 1, 2, 3, 4, 14 twos, right? Well, I've got to get up to the 50th number. So 8 and 14, I'm at 22 here. If I add 27 to that, where am I at? 49. So the last 3 in that list is the 49th number. Does that make sense? I've got 8 ones. Okay, we'll have 8 ones here, right? That's the last one is the 8th number, right? I have 14 twos. The last 2, I've got 8 ones and 14 twos, so this is the 22nd number. Then I have 27 threes. Well, 27 threes on top of the 22 I already have is at 49. The last 3 is the 49th number. So now what do you think the 50th and 51st number have to be? 4.
4 and 4.
Yeah, 4 and 4. So the median is between 4 and 4. So the median is going to be 4. Like I said, that's a little bit of a tougher one to conceptualize, the median of. But you got it helps if you actually just list them out. There are 8 ones, 14 twos, 27 threes. Let's talk about standard deviation. Sense my hesitation a little bit. So we need to find the deviation. If you remember from last week, the deviations are the number minus the mean. The mean here is 3.4. So this is 1 minus 3.4, which is a negative 2.4. This is 2 minus 3.4, which is a negative 1.4. This is 3 minus 3.4, which is a negative 0.4. This is 4 minus 3.4, which is 0.6. This is 5 minus 3.4, which is 1.6. Now, if you remember last week, we said if we added up all these deviations, they should add to what?
0.
0. If you tried to add these, they will not add to 0. And the reason is there is not just a single negative 2.4. There are 8 of them. Because there were 8 ones. We did that 8 times. There's not a single negative 1.4 because there's 14 of them. The 0.6, there's actually 31 of those. So trying to add them together here would be kind of difficult. Now, if you recall, then our next step was to do what? Square them. Negative 2.4 squared is a positive 5.76. Remember, whenever you square any number, it's always positive. If you enter that in your calculator wrong, if you do this, negative 2.4 and hit x squared, it's going to try to tell you it's a negative 5.76. What did I do wrong?
You don't like the number of parentheses.
Yeah, you have to put that number in parentheses when you square a negative. Any number squared will be a positive result. So negative 2.4 squared is 5.76. Negative 1.4 squared is 1.96. Negative 0.4 squared is 0.16. 0.6 squared is 0.36. And 1.6 squared is 2.56. Does everybody understand where those numbers came from? Any questions?
Why did you highlight those 3 numbers?
I was just using them as examples. All these are the same. But I was just pointing out the fact that there isn't just a single 0.06. There's actually 31 of them. So if you're trying to add the deviations to make them equal 0, it's not going to work at that point. Now the next thing I have to do is I have to account for the fact that there was more than one 1 in here. There were 8 ones. So this number here actually occurs 8 times. So I take each of these squares, I'm going to multiply by the frequency for that value. So 5.76 times 8 is 46.08. 1.96 times what?
14.
14, perfect. It's 27.44. 0.16 is going to be multiplied by 27. 4.32. 0.36 is multiplied by
31.
31. 11.16. And 2.56 is multiplied by 20, so 51.20. Now I can add them all together. I'll let you add them all together.
Okay, I did.
Did 140.20? Okay. So now what do we divide by again when we're doing standard deviation?
The number minus 1.
Perfect. N minus 1. What's n here?
100.
100. So we're going to divide by
99.
99. So 140.2 divided by 99 is 1.416. That would be the variance at this point. There's one more step to get the standard deviation, which is to do what? Square root it. You got it. Square root of that answer, 1.19. What that is telling us is that on average, each number is about 1.19 units away from the mean. What do you think? Good stuff?
Alright, you just repeat real quickly, how we got our variation. What minus 1? What was n?
N is the number of items in the list. The total frequency is 100. So there's 100 items in the list.
Okay.
So N is 100. So 100 minus 1 give us 99.
I don't want to sound snarky, but why do I want to know this?
Well, because a lot of times, back up here when we were doing the z-scores and the empirical rule and stuff, somebody's got to find that standard deviation. So you might be given a table of stuff like this and have to calculate that mean and standard deviation off of this table, because normally you're not given the sets we've seen have been 5 to 10 numbers. Normally you're not going to be given 5 to 10 numbers. You're going to be given 100 or more. And those numbers, rather than listing them all out individually, it's nice to be able to do them out of a table. Now, personally, I wouldn't do them like this. That's why I left Excel up. I would use Excel as my friend. So let's say we want to survey students for the number of kids they have.
So can I ask one question? So we
Sure.
found out the standard deviation of classes was
Yep.
basically 1.19. So the standard deviation was that there was a little over one class difference in everybody's answer. Is that right?
Well, let's look at it this way. What this is saying, we found the mean is 3.4. Standard deviation of 1.19. So this would be 2.21, 1.02, negative, what, negative 0.17. This would be 4.59, 5.78, 6.97, and put in those percentages. What we could say here, and I'm not going to keep going with the percents, but what we can say here now definitively is we expect 68.26% of students to have between 2.21 and 4.59 classes. Now, obviously, they can't have 0.21 classes, but still, you can come up with those percents within that range. So let's say I'm looking at number of kids that students have. Let's say none of my students have more than 6 kids. And we're going to give this a frequency. I'm going to make this easy on myself. And let's say that of the students I have right now, I have like 140 students this semester. Let's say I have 34 with no kids, 27 with 1 kid, 18 with 2, 8 with 3, 7 with 4, 4 with 5, let's do 3 with 5, and 1 with 6. Don't need it to come out to a nice even number. So n is 98 here. If I'm looking to find the mean, remember the first step in finding the mean is to take the number times the frequency. So I'm going to take the number times the frequency. 0 times 34, of course, is 0. 1 times 27 better be 27. 2 times 18 is 36. Right on down. I find the total of that. If I add those all up, I get 136. So my mean is found by dividing the 136 divided by the 98. So I have a mean of 1.38. I would probably round that to 1.4. Remember we said round your mean to 1 decimal place past the data. So there's my mean. If I am looking to find my standard deviation now, I have to find the deviations, which is going to be the number minus the mean. So I'm going to take this number minus my mean. I'll do that all the way down. Those are my deviations. And I'm going to square it. Then I'm going to multiply that number times the frequency. So this number times the frequency. Oops. So equals this number times the frequency. Works out better. And then I'm going to find the total of those right there. I'm going to divide by what? Not 98, but 97. Why 97? Okay, n is 98, so n minus 1 is 97. So I divide that out. 2.1164 would be my variance. My standard deviation is then going to be the square root of that. So 1.45 is my standard deviation. So you can see with technology, it's not that hard to do. I can get it done very quickly. And like I said, this curve, these numbers allow me to make that bell curve. Now, how useful that bell curve is to looking at the number of kids my students have, maybe not so much, but looking at prices of homes and stuff like that. Now, a lot of data, we're looking here at discrete data with a low number of items. Remember, we talked about those different frequency tables last week. Here, this is where we can count them, 0, 1, 2, 3, 4, 5, 6. If you're looking at home prices, you might have to do home prices in a little bit different manner. Let me show you what I mean there. Let's say I'm going to do just a quick little function to give me home prices. To give me a sample of selling prices for homes. I'm going to look at 18 numbers. What I did is I just repasted them so that they are not random numbers, so they don't change on me. So these are 18 different homes that have sold recently. I'm not going to list out, none of those two prices are the same. So what I'm going to do here is I'm going to create ranges. Now I'm going to sort these from smallest to largest. So I know my smallest one is 93 and my largest one's 136. 137. So my ranges have to go from 93 to 137. So I'm going to do this. I'm going to go from 93,000 to, let's see here, 101,999. Now the reason I went to 101,999 is I can't have any gaps between classes. So my next will go from 102,000 to 110,999. So I go from 111,000 to 119,999. 120,000 to 128,999. 129,000 to 137,999. Now you can see that covers the whole range of data. Nothing's going to fall outside of that. In fact, I'm going to leave a blank column here for just a second because I'm going to need it in a little bit. I'm going to make it look like it's not there. The frequency, well, how many are between 93 and 101? Looks like there's two of them, right? From 101, 102 up to 110, looks like there's only two of them. From 110 to 119, there's four. 120 to 128. It's kind of looks like the mother lode there. There's, was there 8 of them? And then from there on up, it looks like from 129, there's 2, right? See how that sums up. Make sure we got 18, and we do. Now, I can't, to work with these ranges, I can't really do much with them. So what I have to do is I have to find the midpoint for the range. The easiest way to find the midpoint of the range is to take the difference between the beginning of this range, that's the 93,000, and the beginning of this range, the 102,000, and find the middle point. So this is going to be literally 90, well, let's just do it. 93,000 plus 102,000 divided by 2. That's my midpoint, 97,500. And I do that for each of them. I just cheated there, I know. That's my midpoint for each of them. Now that is what I would use for finding my mean and my standard deviation. At this point, you can see these are going to be approximate. So to find my mean, I'm going to take the midpoint now times the frequency because I don't have a single number. I don't have a single number here that I can use, so I have to use that midpoint. Then I find the total of that, and my mean is found by doing this divided by that. So the mean here is approximately 116,167. Now I purposely did this a small enough data set so I could actually find the mean. The real mean of this data set is 117,697. So you can see it's close, but it's not exact. I'm never going to ask you to do this in this class. I might ask you to do this, where you have the single values instead of ranges. We'll see what mood I'm in when I touch up our test. I usually adjust the tests. If I'm in a good mood, I might just put that on there as an extra credit question. Any questions? It's about 7 minutes early to take our second break, but let's go ahead and do that anyway. Let's take our break. Let's come back in here about 7:23.